We want to continue looking at examples of the chain rule because it can take a little while to get used to it, but hopefully it starts to become a little bit more natural as you get practice with this. What we want to do, again here we'll approach a little bit differently, but with the same goal in mind, is just identify that interior function, which in this case is 2x to the 6th minus 2x to the 5th. To find c prime of x then, we'll follow the derivative rule for that outer function, so we have a power function. We also have this coefficient in front. So this will be 3 times 2x to the 6th minus 2x to the 5th squared times the derivative of that interior function. We can go ahead and multiply together to get 15 times the quantity 2x to the 6th minus 2x to the 5th squared. And then taking the derivative of this interior function, we'll get 12x to the 5th minus 10x to the 4th. And from there we could multiply through to expand, but we're not really going to get anything else to simplify or reduce without kind of a lot of work, so we'll just leave that problem there. In example 6, we have the interior function 4x to the 4th minus 2 being plugged into a natural log function. So to find d over dx of p of x, we'll take the derivative and we'll get 1 over 4x to the 4th minus 2 times the derivative of that interior function. And the derivative of that interior function will be 16x cubed minus 0, if we want to include that there as a placeholder. So our final answer will be 16x cubed over 4x to the 4th minus 2. And actually I shouldn't call that our final answer because we can reduce a little bit here. Each of these coefficients is divisible by 2, meaning we can take one last step to reduce this down to 8x cubed divided by 2x to the 4th minus 1. In example 7, we have e raised to this more complicated power, so that's our interior function, 3x to the 6th plus 2x to the 4th. So to find dr over dx, we'll take the derivative following the rule for exponential functions. So e to the x, e raised to that more complicated expression stays exactly the same, and then we'll multiply by the derivative of that interior function. And the derivative of that interior function will be 18x to the 5th plus 8x to the 3rd.